we're going to go ahead and get started. It's 5 past, half past. So if everyone wants to take their seats, we want to make sure we have time for the keynote to get started when we have scheduled it. So, welcome to DevConf US 2018. And if you spare me, I would like to take a selfie. Wave. All right, obligatory, sorry. My name is Chris Ward. I'll let the others who come after me introduce themselves. I run DevConf in Czech Republic and also am helping kind of expand DevConf around the world. And we are here today at the first annual event in the States, here in Boston. Awesome, incredibly, not even fair, beautifully offered to us the Boston University. And if you haven't had a chance to take a look around, please do. And DevConf, well, let me see, got some slides here. This is an event sponsored by Red Hat, and this year, really, why we're here is for giving back to community. Okay, we're all active contributors, I'm sure, and if we're not, we'd like to be. And this is meant to be a place and a space for getting to know your neighbor, teaching someone something, sharing what you know, pulling more contributors into your project, getting people excited about what it is that we're doing. And we'd like to say that this event right now, it's primarily driven by Red Hatters. But at the end of the day, we want this to be a community event, so driven not just by Red Hatters. If you're interested, I would like to just extend an invitation to share your interest with us by sending an email to us or talking to one of the active co-chairs or one of the volunteers, just to let us know that you would like to in some way volunteer in a future event or become an organizer. And of course, many of you will notice that the lineup of speakers is full of community contributors outside of Red Hat as well as Red Hatters. But we have CFPs, call for participation across the world now for different events. And we will hope that another Boston event will come around. So if you would like to keep track of what's going on and participate going forward, you can subscribe to our general announcement list, and I strongly suggest that you do. Because last week we ran DevConf India, and that was a huge success, and that was also the first time we ran the event. And we expect to run those again going forward. And the announcement that I'd like to make before I hand over the mic to Langdon and Hugh is that we also have a event in Czech Republic, which is the biggest DevConf event. The CFP we are opening up today. So if you'd like to come join us there, then that's a great opportunity. You can follow the CFP at DevConf Info CFP and submit your talks there. With that, really don't want to take any more time. Just want to say welcome to the DevConf community, and please do say hi to your neighbor, introduce yourselves, and let's do some awesome things over this coming weekend. Welcome to DevConf, and pass the mic to give us more information about DevConf US to Langdon White, who will then pass the mic over to Hugh to tell us about the keynoter.
Hi, everybody. So we have some slides you may have seen if you've gone to DevConf CZ before, because they're clearly stolen. So let me just see if I can get to the right spot. So I'm doing mostly the brass tacks side of the talk here. So we don't don't actually have full signs, but I kind of liked how this works. So there will be people outside the doors. If the room is full, please just respect that. There is live streaming of basically all the talks at all times. There will also be videos cut up from that put on YouTube after the conference. So if you do miss something you wanted to see, you can follow it later. And let's see, so try to keep it clean, put stuff in trash cans, that kind of thing. Let's see what else we got. So, the conference, if you've been to conferences before, you know this, but if you haven't been to too many, is a big part of it is the hallway track, as well as the talks themselves. Make sure you meet people. Make sure you go up to somebody and say hi. And that way you can get a better experience coming out of the conference. You might meet some new friends. You might meet your next employer. Who knows? So definitely try to talk to people. Talk to the people out of the booths. They're here because they want to promote the organization they're affiliated with, but they also like to talk to people about what your experiences are with their products or their software or whatever it is they produce. So make sure you talk to people. It's really important. Otherwise, you may not get the full experience out of it. I also wanted to mention we do have this coaching and apprenticeship program that we're trying out for the first time. So it's had some bumps, but we're really excited about it. We're really proud of it. So thank you to anyone who decided to be a coach, and thank you for admitting that you're kind of junior status for anyone who is an apprentice. And hopefully we can have more success with that next year. And let's see, so there's the streaming. So you can find those there now, or you can find them also there later with the cut-ups. We like to point this out. DevConf CZ has a well-established tradition of making everyone sick. Hopefully we are not going to do that at DevConf US. But do keep in mind, it is a closed place, so if you are not feeling well, maybe you should just watch the streaming version. All right, moving on. Wi-Fi. Here's the Wi-Fi. It is also on the back of your badge, so you don't necessarily need to take a picture of this. You can also ask almost everyone, because enough of us have had enough of a hard time logging in that I think all the volunteers have memorized it at this point. So try it out. If you have trouble with it, especially the login part of it, and where's Bex when I need him? But you can actually just go to if you go to a regular browser, what's the URL? SafeConnect. Right, so if you go to a regular browser and go to safeconnect.bu.edu, sometimes you have better luck than the kind of weird built-in sort of browser that they have for the sign-ins, both on mobile and on laptops. I can't speak to anything besides Fedora because, it's the best. All right, let's see what else. Oh, that's what I just said. All right, moving on. For lunch, everybody likes lunch. We have a vegan option and we have a non-veg option. There is no vegetarian option. Vegetarians are not on the menu. And so if you have any other concerns, for example, myself, I'm gluten-free, just speak to any of the staff. You can find a volunteer and they will find you a staff member, or you can talk to the staff. We do have other options in the back, or we can tell you more detailed ingredients. The top 8 are actually listed on the lunches if you have any food allergies or concerns or intolerances. So just, read the signs or ask someone if you need any more detail. There is also one talk that I'm referring to as the Easter egg talk. It is completely unrelated to anything related to software. It is maybe a joke, maybe not. You have to find it, you have to attend it. It's hilarious. So I highly recommend it, but I'm not going to tell you anything else about it. All right. To date myself, there was a movie way back in prehistory called Bill and Ted's Excellent Adventure. It was an awesome movie. They're talking about doing a remake, which I think is a terrible idea. And there's a great quote in it: be excellent to each other, okay? We have an official code of conduct, but this kind of surmises it, right? Don't be that guy, right? Or don't be that gal. If you have any, let's see. So we have a couple of different options here. If you have a straight up emergency, please call campus police. They are actually integrated with Boston Police, and you will actually have a faster response than if you call 911. 911 directly. If, however, you do not have a US phone, that's a hard number to call. So you can still call 911 if necessary, because any phone in the US, I believe, is required by law to be able to call 911. So try to use the campus police number, because it will actually be a faster response. If you have a code of conduct concern that is something that you want to bring up with someone, find a volunteer. They will find the appropriate person to respond to that. If you are uncomfortable with talking to a volunteer about it, you can call myself. I'm Langdon. There's my phone number. Please try not to pass it out to everybody. Or you can call Marina. No. Yeah, it's too late now. Or you can call Marina. She's right there. She's going to stand up or wave and say hi if you have any concerns whatsoever. All right, there is a party at 7 p.m. tomorrow night. At 11 o'clock last night, I said, you know what, I don't care anymore, and I'm not going to find tickets. So we did not have the tickets this morning. We apparently may have them now. However, I'm kind of thinking that maybe we should pass them out at registration tomorrow anyway. So it'll be first come, first serve. We may not give them all immediate out at registration, because I don't like to favor all the really early risers, because I'm not an early riser. So you need a ticket. There are not that many. If you get a ticket and end up not being able to go, please give your ticket either back to a volunteer or to someone else, okay? That's all I have to say about tickets. It is, per the fun committee, the funnest party you'll ever go to. So, just fair warning. Let's see, what else we got here? The closing ceremony. In the tradition of the DevConf in the Czech Republic, we will be doing a closing ceremony that has a game and it has prizes. So you may want to stick around for that. It should be a lot of fun. I will not be doing it, so therefore it's more likely to be fun. And I am really disappointed that I'm not actually in this picture, but whatever. All right, what else? Social channels. This is the social stuff. We would love the promotion, right? We want more people to sign up and attend and all those sorts of things. So please do your best to, tweet about it, to, use Facebook, whatever the cool kids are using today. I believe that's Instagram, but, whatever. Please let us know. You can also contact us on Twitter if you're looking for a volunteer or something and you can't find one. That's a reasonably good way. We're also on Telegram. There's a attendee chat. If you have a problem or whatever, you can also we're usually monitoring that, but there's a lot of just chat there, so we may miss it. Okay, so the other thing is also kind of in the tradition of DevConf, people like to take a lot of pictures at these conferences. If you do not like to be in pictures, we will try to honor that if we can. Just let the photographer know, okay? But people will be taking a lot of pictures. And apparently we're done. I don't know why. Oh, yeah, I guess that's it. I thought I had one more slide. So I am going to hand it off to Hugh, who is going to talk to you about the kind of the session side of the conference.
Right. Ready? Thank you, Langdon. Let me find my notes. Give me a second, folks. That's so I can be in stereo. Normally I don't use notes, but I don't want to forget anybody. So thank you all very much for coming. It's great to see you here. This, I hope, is the first of many DevConfs that we will do here in Boston. It is not, however, the first DevConf, as Chris mentioned. The first DevConf that we, Red Hat, were involved in was in 2007, I believe, 11 years ago in Brno in the Czech Republic. How many of you here have attended the Brno edition of DevConf? Okay, that's a good number. So about a third of you know exactly what I'm talking about. The first time I went to one, it was only the second time I'd been to Brno, and I think I had 3 responses. The first one was, what the heck is this? I couldn't really figure it out. It was not like any conference I had ever seen before. partly because it seemed to be completely self-organized, and even despite being self-organized, it actually worked. Those were two sort of amazing things. The second thing was, holy crap, it's cold. Brno in January. Sometimes it's warm, not usually, as I learned when I moved there later. And the third thing was, who is this big tall guy who seems to be running everything? Radek Gokal, who could not be here today, but I wanted to recognize him because his spirit is the inspiration behind all of this stuff. And we miss him here. It would be good if he could have made it. So why do we do DevConf? If you've ever looked for DevConf on the web, you've seen that there must be 150, 200 of them. We think this one is special because it is an open source conference run by and for open source developers, and it is about open source development. It's not about a particular project or a particular company or a particular area of technology. It's about the art of developing open source software and the challenges that we encounter in doing that. And I think that's really important, and I think it's one of the special things about what we're going to do today and this weekend. So why do we care about that? In an open source world, we're all here because we think open source development and the open source methodology is important, I think. Today, however, and Daniel Reek's going to talk a lot more about this in his talks later today, data is as important as source code. We're entering an era where it will be impossible to do compute unless you have access to data. And the question of having access to data is very much open and in debate. There are just as many companies trying to play in a closed data world, Microsoft, Siemens, GE, Apple, for example, as there are smaller companies and smaller groups of people like us trying to keep data in the open and available where anybody can do compute on it. So that's going to be a theme that you'll see today. We have a number of conferences talking about how can you work with open data and how can we keep data open. And one of the reasons I wanted to ask Andre Lopez to speak to you this morning is that this is one of the things that he holds dear. DevConf also has a special emphasis on students, student researchers, and we have a lot of that today. We have student posters over here in the back of the room. Some of them are here, some of them are still sleeping. I expect they will be here later. Please do check out the posters when you get a chance. We also have a lot of first-time speakers, so be sure to give them a really hard time. No, don't actually give them a really hard time. Be very nice to them. We have a lot of people who don't do a lot of talks, and we want to support them, and so that they will come back and do more talks. This is very important. We also have, I'm very proud to say that we have with us today 11 diversity scholarship recipients. This is the first time we've done this at a DevConf. We came up with some money to bring people here who otherwise would not have been able to come. Several of them are graduate students in CS. Several more are mothers who either took career breaks when they had children or are trying now to define new careers for themselves. And I'm just really proud that we were able to bring them here. One of them is a veteran who's just left the service. And we welcome you especially and hope that you all have a great time while you're here. I should quickly thank the people who have helped us put this together. David Cantrell is wrangling the volunteers. Thank you, David. Langdon White, of course, who just spoke to you, has actually done all the work, although I'm going to take all the credit if I can. Daniel Reek has spent weeks getting our video streaming together. Because of him, you can see all of this stuff live on YouTube, which is pretty cool. Jen Madriaga actually did all the work. She's sitting here in the front row. She is one of our sort of lead event planner for this and has been tireless. And finally, special thanks to Marina Zhurakinskaya, I think I got that roughly correct, who leads our diversity initiatives and was responsible for putting together the scholarship program. So I first met Andre Lopetz at the Hariri Institute, where I spent a lot of my time over here at BU. It's really refreshing to meet a researcher in CS who is as passionate about open source as Andre is. Not only is he passionate about it, his work involves taking what used to be one-time academic software that was written for projects and then died, and building long-term upstream communities around that work. And I think it's really interesting and really inspiring, and I know you're going to enjoy hearing from him. So Andre, if you're ready, I think we might as well get started.
5 minutes, they need to refocus.
Oh, okay, hang on. Chris is telling me we need to refocus the camera. Roger that.
Yeah, I'll try. Thank you. How would I do that? Step 5. Okay, thank you very much. So I apologize, I have a cold today, so your experience will not be uniform throughout the talk listening to me. So I'm Andre Lapitz. I'm a computer science faculty at Boston University, and I also direct the Software and Application Innovation Lab, and I'm also involved in something called the Hariri Institute. So I'll tell you about some of these. I assume that one of the reasons I was invited here, as Hugh mentioned, was to kind of introduce BU and what's happening at BU to everyone. Now I should make the disclaimer that this is nowhere near everything that's happening at BU. This is just things that we're involved in, or that I've been involved in, or that I'm peripheral to, that I'm aware of. But hopefully it'll give everyone an idea of the kinds of things that are happening at BU that are related or would benefit from open source, or where open source is kind of incipient in certain communities. So it's just an overview. First I'll talk about the Hariri Institute and the Software and Application Innovation Lab, and then I'll go over a couple of examples of work going on at BU that involves open source, or is starting to involve open source, that again we're involved in. And I'll talk a little bit about sort of the challenges and advantages and so on of trying to bring open source as well as bring software engineering into an academic environment in the way that we are currently doing it. So the Hariri Institute for Computing was founded about 6 years ago now to help researchers across Boston University who have a software engineering, computer science, data science, computational component to their research, all the way from biologists and physicists all the way down to even School of Theology, and we do work with School of Theology and the humanities and things like that. And the Hariri Institute supports these kinds of efforts through seed grants, through recognition of faculty and graduate students through fellowships, but it also hosts sort of a federation of different centers, labs, and initiatives. Some of them it incubates, some of them it sort of took on after it was formed, and many of these are around specific topic areas like artificial intelligence. Others are meant to promote things like digital education or software engineering in the case of the Software and Application Innovation Lab, as well as other sort of areas of interest or focus. So software engineering within an academic environment is something that it seems is starting to become recognized as a possible career in a way that it wasn't before. So what I'm talking about here is the standard career tracks involve you become a PhD student, then you become a postdoc, then you become a faculty member, and those kinds of tracks in academia are well recognized, and there's broadly well-organized structures for people to progress through those throughout their career. Not so much for research software engineering yet, although if you look online, you can see that these things are starting to improve. You have, in the United Kingdom, for example, you have these sort of trade groups and associations and conferences for research software engineers who actually want to build a career doing software engineering and bringing best practices from software engineering into the academic environment. And you have other examples in the United States where For example, the Flatiron Institute, I think it's called, was founded in New York City to help researchers with sort of computational challenges. And it was, it's a very large, sort of well-funded group. So things are starting to happen, and we're basically trying to do that at Boston University. So about 3 years ago, with this goal in mind, we started the Software and Application Innovation Lab at Boston University. And the idea here was to augment what the Institute was doing in helping researchers and faculty members and students introduce computational and software engineering elements into their research. We grew very rapidly just because there's a lot of demand for this kind of thing. So initially it was primarily to support the seed grants, where the Hariri Institute was supporting these kinds of efforts. But it turned out there's a lot of researchers who have funding, and I'll talk about this a little bit later, who have funding from external funding sources where academics typically get the bulk of their funding. So these are national organizations like the National Institutes of Health or the National Science Foundation, as well as foundations and other sources. DARPA, IARPA, and so on. In this case, what was very interesting is that it also allowed us to take existing research efforts that maybe weren't able to get funding from those sources, because those organizations themselves are starting to recognize that you need to actually support software engineering as an end in of itself in many fields if you're going to actually improve those communities, and you'll see some examples of that. Improve the way those communities work together and the way they build tools and so on. So basically, because the Hariri Institute is kind of a hub at the university and talks to researchers all around about the research they're planning to do or the research they're currently doing, then it really puts the Institute in a good position to promote things like open source approaches. So it's true that we've observed in many cases over the past several years situations where outside contractors were being hired and basically they were rebuilding the same thing over and over again. In some cases, what you might arguably say is a waste of federal funding. But it's simply because people weren't familiar with the fact that you can actually take a piece of software and separate it into an open source component, which is reusable, and you can probably reuse it not only just within one group or within one project, but probably across projects. But also that you can take your proprietary research or whatever it is that you're building, and you can sort of isolate it so that it becomes a configuration or an instantiation or a parameter to that open source platform. So you can still have your IP, but you'd be able to build this kind of infrastructure that's reusable. And it also puts us in a good position to promote best practices. So, documenting your code. We've had experiences where we had to rebuild things from screenshots, using CI/CD, making sure that you use good version control and things like that. So these are things that we're able to promote and actually teach people about throughout the BU community because of the position that we're in, because we're working with so many groups and talking to so many groups. One thing that I will say though is a lot of the things that I'll talk about and that we do are application level development. So there are many groups, and you'll hear from other groups at BU who do other kinds of work, but we specifically focus on sort of applications and things at the application layer. So frameworks, libraries, web services, full stack applications, and so on. We have I'll mention some things that also were production quality. So we've built things that are production quality and had to be deployed. Other things are more kind of prototypes or things that are facing users who happen to be researchers. So I'll go over these four topic areas that I chose where it's exciting to see sort of open source approaches being adopted. So one of them is actually experimental design and automation in synthetic biology. So synthetic biology, it's kind of there's lots of things going on there, but sort of one prototypical workflow that I'll focus on, that there's some projects that are funding work on, is this idea of, if I'm going to build these genetic components that essentially implement logical, programmatic kinds of algorithms, and I'm going to, explore different designs to see which ones actually have the behavior that I want. So an example application of this is something like, I want to create some kind of organism that will detect contaminants in water by, maybe glowing or something like that. So you can actually online right now buy a kit to do genetic engineering. You can do it at home. You just need to order one online. So these kinds of things exist, but here we're talking about sort of automating this on a mass scale. So basically what you're going from is a design to hopefully some kind of automated infrastructure, APIs, all the way down to machines that are actually going to run the experiments and synthesize biological components that have certain functionalities. So what's really interesting is that, for example, DARPA is actually funding an effort called Synergistic Discovery and Design, which is, BU is involved in actually a broader group that includes the Broad Institute at MIT and others. And Doug Densmore is one of the PIs here at BU who does this work. But this program is actually explicitly designed to say, all right, all of you labs that are sort of doing synthetic biology and are planning to create pipelines that build these components that are essentially biological systems that perform certain functions, you guys need to agree on standards that you're going to use. What kind of APIs are you going to use? What kind of formats are you going to use for describing an experiment, for describing a biological component, and so on. And it's actually really interesting to see, they're actually doing things in the way that you would expect, and in the way that we see other open source communities doing things. They have consortia, they have working groups, they put together standards, and DARPA is actually funding this kind of thing explicitly and encouraging this kind of work. So specifically, for example, something we've been involved in is a number of different tools within workflows where we've contributed to existing standards as well as existing tools within the community. When you need to, for example, build these biological components, there's a standard language for visualizing these, and it's amazing to see the synthetic biologists actually on a whiteboard write it so fluently as if they're just writing in English or something like that. But these sorts of images are actually rendered in various tools so that you can actually present them or examine them and things like that. So we've had contributions where we've added the ability to visualize additional kinds of components within tools like Visbol. We've also contributed to several tools for essentially generating design. So if I want to have some kind of logical circuit and I want to implement it as some kind of biological system, there's tools like Cello that being worked on, including by groups at BU that I mentioned, that essentially take that logical circuit and generate a bunch of biological designs that could implement that circuit. And then of course you need to test and see if they work, and that's part of what this sort of experimental workflow is meant to support. Another standard that's kind of growing right now is SBOL. So this is a standard for, it could be for describing biological components, it could be for describing experiments, and it's an RDF-based kind of XML format, and it's actually expanding right now as the community decides what kinds of features should be added to it to describe the kinds of biological components that they want to build. One thing that I was really happy and impressed by was this open source protocol called Outer Protocol, which is intended primarily for robots. So essentially these are these pipette robots that I had a picture of here earlier on the right side. And basically the idea is that you'd have this JSON format for saying take this pipette, move this much of this material into this particular well, and it's a programmatic way to describe this kind of process. But it's very interesting. If you go to outerprotocol.org, you'll see that it just looks like an API, and this community has actually done a great job of taking the kinds of techniques that we're familiar with from software engineering and adapting it to this particular domain. It's very encouraging to see that, and it's very refreshing to use this kind of tool and use this kind of format when you're building pieces of software. So that's one area where it's definitely exciting to see these kinds of software engineering and open source techniques being introduced, and we're very happy that we have the opportunity to contribute to these here at BU within the Software and Application Innovation Lab, and for the Hurry Institute to be able to support this kind of work as well. So there's another area where we're seeing things change and kind of emerge right now called digital and electronic health, and the Hurry Institute, as well as some other groups like the Institute for Health Science Innovation Policy, as well as the Mobile and Electronic Health Affinity Research Collaborative. These are some of the entities at BU that support or are kind of encouraging some of these things to happen. But here I have an example of sort of a series of projects that we're doing with some of the faculty members at School of Public Health in building something called computerized adaptive testing platforms. So these are platforms that basically allow organizations like healthcare providers, hospitals, nonprofits, to provide assessments that either could be administered by clinicians or can be sort of self-administered by patients and users to assess their progress if they have, for example, spinal cord injury, or if they have burn injury, or if they have other conditions, or maybe just sort of how they're progressing and what their condition is if they're healthy. And these tools actually, when we came into this community, many of them were being built using, Visual Basic 5, and they were running on Windows XP desktops and things like that. It was very interesting to come into this community and try to introduce sort of full stack web applications using open source frameworks to build both the back end and the front end components, and to also make them, as a result, cross-platform, more compatible with sort of web-based environments. And now we've actually, had great experiences, taking some of these organizations on the right-hand side and helping them deploy these tools using modern techniques. So we're using Docker, giving them these Docker images, allowing them to set this up within their environment, and it's really been great to do that. And one of the interesting things that we've run into here is actually a lot of these tools have to be accessible in the sense of if you have users who may be hearing or sight impaired, and they need to be able to use these websites nevertheless. And one of the things that we've actually run into is there is a government, funded framework called Assets that really isn't maintained very well. And we've ended up actually having to use one with a not so great license called Accessible Plus. For some of these tools, but we're actually thinking about right now coming up with sort of taking Assets and maybe fixing it up ourselves here at BU, given the number of projects that could benefit from this. But the idea here is that this is a front-end framework that allows you to introduce components into your web application, into your website, that makes it accessible in accordance with standards like Section 508. This is something where there's a lot of opportunity here also for private organizations as well as nonprofits and academic actors to get in and sort of improve this and maybe contribute in places where, for example, the government may not have the resources to maintain these things. I have here Web Experience Toolkit, which is actually a Canadian government-funded project as well, just for complete coverage. But these are examples of things where open source is actually, open source approaches are also going to be very valuable. Obviously, this is something that benefits many users and is essential for many of these applications, and this is where those techniques can provide lots of benefits. So here within BU, there's another project that we're working on where it was just, showed us how important it is to use good software engineering practices. Margaret Betke is actually on top here. She's a faculty member within the CS department, and she's working with another faculty member in the College of Health and Rehabilitation Sciences here at BU to build this system that uses, well, it'll be other things because the Connect is discontinued, but at the moment we're using a Microsoft Connect to essentially allow patients to adhere to exercises, for example, physical therapy exercises that they have to do at home. And one thing that's interesting about projects like this is they really are, heavy software engineering projects. There's a team of 20 people with PhD students and software engineers and project managers all trying to, collect requirements, build mock-ups, put together user interfaces, put together the back end, take components that are research components. These are things that are algorithms that PhD students are putting together for their theses, and helping the PhD students get them to the point where they're production quality, so you can actually have patients using this and not being frustrated. And there's a lot of project management that goes into this kind of work. There's a lot of coordination, and in this case, we're also using open source approaches as well as using open source frameworks. So it's a really great opportunity for sort of demonstrating how valuable it is to use these approaches for these kinds of projects that probably wouldn't have made it this far without sort of using sort of industry and community best practices for something this complicated. So that's another ongoing project that's happening right now within this kind of digital and electronic health space. So I'll switch over to another, a third example area where I'm personally very involved in, and we have a lot of work in this. So So there's, next generation cryptographic techniques you've probably heard of, homomorphic encryption, and there's another thing called multi-party computation. And basically, these techniques allow you to factor out what used to be things that you assume have to go together. So you assume that if you want to take data from multiple organizations and do some kind of joint computation over it to analyze it, you would assume that you need to actually share that data, give it to some party, and then it'll do the computation. It turns out with techniques like multi-party computation and homomorphic encryption and so on, you can actually separate computation from actually being able to read and hold the data. I can, for example, encrypt my data, give it to some kind of service provider. They do the analysis without ever seeing the data or the results. They give me back the encrypted results. I decrypt the results and I look at them. So these things are all are all possible, but these are not techniques that are currently being used in production, in the real world. And one of the things that we currently have is a bunch of grants from the National Science Foundation as well as other partners that are explicitly for building open source libraries that will then allow others to build applications and services on top of these open source libraries to introduce these kinds of features into their applications. So here we have a list of different libraries, and there's other talks that you'll hear during this conference about some of these, like for example Conclave, as well as the applications where they're being used. But we're essentially being funded by NSF to build libraries that are open source and that can be sort of deployed and used within applications. And, excuse me, we've actually been able to take some of these and deploy them, which I'll mention in a second. Now, one approach that we've taken here when we started this is there are a lot of libraries obviously being put together within this community by researchers, faculty members, graduate students. But one of the approaches that we took when we started building some of these in particular, because we knew we needed to deploy them. We knew we needed to deploy them for applications that are basically going to run at the on browsers that end users are using on their laptops and so on. We actually had to, from scratch, build them using JavaScript, for example, so that they run on all the browsers and that you can build applications that are compatible on all browsers. So this is a library called JavaScript, implementation of federated functionalities that we built to support those kinds of environments. And there's lots of demos online that you can look at. And you kind of see these libraries from a few slides ago, sort of where they went or where they're going now. So we have collaborations with the City of Boston, the Boston Women's Workforce Council, where these libraries were actually used to build applications that have been deployed over the past 3 years or so in production, used by hundreds of companies across Boston, where they're basically loading this application in the browser and contributing data to a computation in a privacy-preserving way. We have a partnership with Honda Research Institutes, and this is to Honda Research Institute's credit that it actually is supporting open source development. So they're funding this work, but they're funding open source libraries that they hope to benefit from as well. And we've actually built prototypes and demos of things like, so let's say you have Google's routing service, right? So Google allows you to say, I'm here, I want to go there, and it returns to you sort of a path of how to get to that destination. So you can actually build that service in a way such that Google never sees your query. It doesn't know where you're starting and it doesn't know where you're going. Nevertheless, it's able to tell you how to get there. So you can do this in a privacy-preserving way using these techniques and using these kinds of libraries that we've put together. We've been fortunate to work with the Callisto project as well. We've put together some libraries that allow them to use multi-party computation techniques within their service. Callisto is a sexual assault reporting service that runs on a number of campuses right now, and they're building sort of a next-generation version of their offering that is going to use some of these next-generation cryptographic techniques, and we were able to put together some open-source libraries thanks to the NSF funding for them as well. And as I mentioned, you'll hear about Conclave, which is another project that involves the Massachusetts Open Cloud, Dataverse, and actually Red Hat, I think, is involved in this as well at this point. And it's a very interesting project. You'll hear more about it in subsequent talks, but one of the libraries there is again something that we've been working on, funded by NSF, that contributes to this project and allows these kinds of privacy-preserving computations to take place within cloud environments. The last topic I'll kind of talk about is urban data science. So BU hosts something called the Initiative on Cities, which was, I think, started by the former mayor. The initiative tries to connect researchers and students at Boston University with cities, in particular the city of Boston, but also other cities in the area, to sort of address issues. And what's interesting over the last 3 to 4 years, maybe even more so, sort of 2 to 3 years, is cities have started to embrace open data, right? So they basically take all the data that used to be in document paper form, or just going into a black hole or some server somewhere and never looked at again. And they've been taking them and turning them into these open data portals that are accessible to everyone. So right now you can go online, you can go to Analyze Boston, and you can see, here's all the bike paths in Boston, here are all the 311 calls, here are all the 911 calls, here's where all the accidents happen. So far it's a difficult challenge for cities to actually go beyond that, because they don't really have the resources to then take that and build solutions based on that data. They're just trying to get the data out there. But they are using sort of open source frameworks like CCAN and Socrata API to do that. But what we've been doing is, for example, supporting student kind of project-based courses, as well as other projects that are funded by NSF, to build tools that use that data, or to build tools that allow others to use that data. So we have this this diagram of this ecosystem, various little components that will allow someone to take, if I have the bike path data set from the city of Boston, can I take that and then, for example, find the most efficient way to connect the bike paths? Where could I place additional bike paths to sort of connect them up and have them have better continuity? So in order to do that, you have to retrieve the data, you have to store it somewhere, you have to build a pipeline that maybe can retrieve updated versions of that data over time. And what you need to do is then maybe run an optimization algorithm over it. But that requires converting that data from whatever GIS format or sort of OpenStreetMap style format it's in to something that's going to be compatible with network hex and Python or something like that. So we've built a lot of libraries and sort of tools to support that kind of thing. And students have been able to contribute as well as use those kinds of tools within courses that are offered at BU, where they use these open data sets and they do projects focused on sort of solving problems with optimization techniques and sort of statistical analysis techniques. We've been able also to do it ourselves in a couple of cases. Recently, Boston had, the Boston Public Schools had a challenge to find a better way to route school buses to reduce costs. It was a little controversial. We were careful to not get into the controversial part of it. We actually what we did was we offered to create an anonymized sort of data set that is representative of the distribution of students in the Boston area, but is not actually the addresses of all the children in the Boston area. And we did that by essentially taking a collection of different open data sets and using a bunch of tools to build something that has the same distribution in terms of the number of students going to number of schools. And you have to get it right. So if you see on the picture on the left here, that just connects every student with a straight line to the school that they attend. In the Boston area, for example, because of the way that Boston assigns students to schools, you see there's a lot of cross traffic north to south there. So it's not terribly efficient in terms of transportation, but you have to kind of create something that's representative of the actual challenges that the routing algorithms might face if they're actually going to figure out how to transport all these students. So this was an opportunity to use some of these tools, use some of these data sets, and for us to kind of get involved in a project that hopefully at least provided a beneficial data set that others could use to do the actual routing challenge. So full disclosure, MIT won the challenge for routing, although again, you can read the newspaper articles to see what the controversy was there. So I wanted to kind of now step back from these specific topic areas and just kind of demonstrate some of the ways in which, by doing all of these things, certainly the Software and Application Innovation Lab at BU has been able to find opportunities to reuse and also leverage our experience working in one area to basically, inform or give us something that we can reuse or have an advantage in another area. So it's just like, we call it the spider diagram sometimes. Some of the projects that we've worked on, some of the tools that we've used to support those projects in particular areas of research. And you can group them in various ways, but this is sort of just one way of grouping some of these projects. So just to give an example, one thing that we've been able to do is build a back-end system that we've reused throughout projects. The back-end system basically does things like user management, authentication, and you can manage data. But we've been able to use it for these computerized adaptive testing platforms. We've been able to use it for synthetic biology databases. We've been able to use it for sort of situations where you need to build tools that are HIPAA compliant. And by taking this open source platform that, again, we've seen people rebuild over and over again, building our own kind of version of it on top of open source frameworks, making it open source, we've actually been able to save a lot of effort on our part, and we've been able to take features that benefit one community and sort of transfer it to another community. And people are starting to accept it. They're starting to understand that, oh, it's okay that I'm going to fund an improvement to this open source project and save some of my funding for the actual work of the research, rather than build the whole thing top to bottom and sort of own everything, which doesn't really benefit anyone, because you're just rebuilding the same kind of backend from scratch each time. Front ends as well, we've kind of embarrassingly reused front end frameworks and components across projects that are vastly different, and yet we've been able to sort of reuse this stuff and again, save effort, get benefits of feature improvements across these projects in these kinds of scenarios. And then just sort of from a competitive advantage standpoint, right? So one of the reasons the Hariri Institute exists at Boston University is to make it possible for researchers to be more competitive when they apply for external funding to NSF, to NIH, and places like that. Among the things that you need to have there is, thank you very much. Appreciate that. So one of the things that you would benefit from is you have built frameworks before, you've worked on, you've used best practices before, and you're able to reuse those and say, I can reuse this in a project if the NSF funds it. Or I'm able to do ask a new kind of question because I ran into it while working on these kinds of projects. So I talked about a little the digital health projects before, where we were able to take things that we're familiar with from software engineering and kind of bring frameworks and best practices into these communities and build all these tools with all these collaborators, and so sort of that's great. But many of these, for example, require HIPAA compliance. So then we can say, okay, well, we have familiarity with that because we do cybersecurity research, we do this sort of next generation cryptography research. We can actually take some of these techniques and bring it into these projects. And now we can, maybe use a slightly more sophisticated form of encryption to manage sort of multiple layers of users and the way that they can have access to different components. So, we can bring that into the frameworks because that we have experience with that. Of course, also builds our own sort of experience, the experience of our interns and so on as we do that. But then you can actually turn around and go back and say, now that I'm in this community, I actually am introduced to new problems that I haven't seen before because I'm familiar with all these members of this community. And now I can actually go back to NSF and say, they actually would benefit from additional kinds of work in cybersecurity and cryptography that hasn't been done yet, but that we could do, and then they would be able to use. And then you can go back to NSF and say, we'd like to do this work, please, please fund it. It'll require some basic research, but then it'll also require us to do the software engineering to put it into production and have patients actually be able to use these features. And we've been able to do that with some partners like, for example, Hey Charlie is a startup that actually tries to address the recidivism in opioid addiction and help patients not sort of return to their bad habits. And one of the things that we were able to do for them is build this kind of encrypted backend that allows them to analyze and store data without actually having to store sensitive data about patients and sort of their histories and so on. Other examples, we've been able, again, to allow students within these urban data science projects to use the Massachusetts Open Cloud, for example, as well as sort of efficient frameworks for doing big data computations in these kinds of environments. And then, again, as a result of us being able to go to the city of Boston and other collaborators and say, here, we've helped you with something, they come back and they trust us to tell us problems. Because if you go, usually if a researcher goes to like the city of Boston and says, we'd like to work with you on something, they're like, who are you? I've never worked with you before. I don't really trust that if some of your students learn about my problem, that they're going to come back a year later or a few months later and actually solve it. But by actually doing something first and building a relationship, you actually get to talk to people and they tell you what their real problems are, and that's how some of this multi-party computation deployment work happened as a result of the fact that we already had relationships with the city of Boston based on previous engagements. And then that goes back into, again, allowing us to ask for funding to do research in cybersecurity, cryptography, and so on for things like multi-party computation. Sorry, I did not plan to get sick. All right, so anyway, so that hopefully gives you an idea of the way that we've been able to leverage the fact that we are using software engineering practices and sort of open source techniques to enrich the research community at BU and to sort of find new opportunities both for researchers as well as for introducing software engineering and open source best practices into these communities. And again, I want to pause and say there's a lot of other things going on at BU. This is just a small slice of things that we've been involved in. There's a lot of things going on at the School of Engineering. There's a lot of things going on even within the Hariri Institute that I haven't mentioned, that again you'll hear in other talks, and I hope you do attend those talks and hear about those other topic areas. But so that's us. We're the Software and Application Innovation Lab, and these are some of our sources of funding now here from these external agencies and other partner organizations that fund the sort of the majority of our work. And thank you very much for listening to what's going on at BU. Hopefully it gives you a better idea of what's happening and also a better idea of the opportunities that you have to engage with the academic community around some of these areas, as well as many others. So thank you very much.
Thanks very much. Thanks, Andre. That's really great. I appreciate the talk. I forgot to mention one thing, which is that in this room here is the Red Hat Boston University Collaboratory Track. All of the talks in this room today will be presented by interns from BU who have been working with us over the summer. So please be sure to check those out if you find them interesting. We got a coffee break now, so get some coffee. Enjoy it. Enjoy this.